Hello everyone, welcome to the Nullcon Webinar series. My name is SASTRI. I am a part of the Nullcon team and also your host for today. So let me briefly talk about Nullcon. The Nullcon conference is a unique platform for security companies and evangelists to showcase their research and technology to the community. We have been running Nullcon security conferences since 2010, where information security is discussed in detail among the industry, government, and tech community. In this work from home environment, we keep continuing to share our knowledge and connect with our global community by running multiple online events like webinars, workshops, training, and resume cleaning. And also in the coming time, we are going to have some exciting sessions on ransomware, information warfare, e-commerce, cyber attacks, telecom network security, and many more. Also happy to let you know that we have announced our Nullcon security training in the online edition, which will happen from 23rd September to 26th September 2021. More details will be given out in the chat box. Coming to our guest speaker, today we have with us Rushikesh Nandedkar, and he is going to conduct a special workshop on the crash course, a non-programmer's guide to fuzzing. Having more than 10 years of experience under his belt, Rushikesh is a researcher. His assignments have always been pointed towards reducing the states of insecurity for information. His research papers were accepted at Nullcon, BruCON, Blackhat USA Arsenal, DEFCON, X33FCon, BSides Delhi, HITCON, HITCON, and other renowned events. So on behalf of all of us, I welcome Rushikesh to this session. And lastly, before we go ahead, a few instructions for the audience. So today's session is for 2 hours, followed by a Q&A session. And if you have any questions at any point, you can drop them in the chat box. And I also request you all to keep your mic on mute during the session so that there is no disturbance. And without any further delay, I request Rushikesh to take over the session.
Thank you, Sakshi. So let's begin with a screen share. Give me a moment. I'm just sharing my screen. Awesome. Is my screen visible?
Yes, it's visible.
Awesome. So hello all. Let's begin the learning. So today we would be trying to learn something about a very interesting method of finding vulnerabilities in applications, and that's called as fuzzing. Yeah, so today's session's agenda would be something like this: an introduction to fuzzing, then fuzzing as a process, like what exactly we try to do in fuzzing, then types of fuzzing, mutation-based fuzzing. We won't be covering generation-based fuzzing. So that's it. Already Sakshi gave you some information, so there's no point again repeating about myself. So motives and thoughts, like why are we trying to, or rather why am I delivering this session? Long back when I started learning about fuzzing and doing fuzzing, there were not many resources available, neither online nor offline. People used to be a little more aggressive about that, and that was the reason, like, the learning curve involved in fuzzing was quite steep. Those who had like a real core programming background, when I say core programming, low-level programming, so those guys, they simply floated through this whole learning process of fuzzing. But people like me who had no programming background struggled a lot. So please don't consider this as a discussion on negative note, but then what I realized, like, okay, this is not a problem if a non-programmer want to fudge some target and find some interesting bugs for whatever purpose they want to. So is the reason I started thinking on similar lines, and thanks to Nullcon giving me an opportunity to deliver this workshop to non-programmers. Programmers are welcome. They would be easily sailing through this whole session and maybe in their endeavors as well. But for non-programmers, it might take some time, a little more hand-holding. So don't worry, I'm here. Whatever questions you have, whatever problems you face, I'm here to help you with. So that's most of it, like motives and thoughts. So what is fuzzing? Fuzzing is nothing but an automated software testing technique, which actually consists of creating some interesting inputs. When I say interesting, that is through security point of view as of now. Okay, so creating some interesting inputs. So technically those are either invalid or unexpected or random or something that an application will not anticipate to receive or consume. So these inputs are to be built and then fed to an application, and then we are supposed to observe the behavior of application for that particular input. If the program does something which it shouldn't, then that is kind of we can say an unexpected behavior. If the program does, if the program behaves unexpectedly through a memory standpoint, where it is trying to access, when I say access, it could be either read or write an invalid part of memory, then that is called as a memory corruption bug. I'm trying to explain everything as if the audience is having mixed blade, like as if somebody is not at all aware of what exactly a memory is or something like that. So I'm trying to give you some basic information about it. You can always go through various resources available online, and then okay, so that's it. So the program is then monitored for exceptions such as crashes, failing built-in code assertions, or potential memory leaks. So is the reason whenever it comes to software vulnerability part, as far as memory corruptions are concerned, majority of the times crashes are valued more compared to built-in code assertions or memory leaks. Majority of the times. That's not always true, but majority of the times. So is the reason I have highlighted crashes in red. So that's a bit of formal definition of fuzzing. So why exactly one should do fuzzing? So there are like two basic aspects we can consider for companies and for security researchers. For companies, for product security engineers who are testing their products security in-house or something, for them it is an awesome tool to stress test their products, and it is equally an awesome tool to find security vulnerabilities as well. Not many companies nowadays actually develop something in C and C++, of which we would be, how to fuzz C and C++ programs is our basic theme. But otherwise as well, fuzzing is not only restricted to C and C++ programs, it's actually applicable to every possible target which consumes an input and does some behavior depending upon the input. And for security researchers, why one should fuzz? Security researchers usually fuzz the programs or applications or protocols for vulnerability research purpose, for writing exploits out of the they have, for finding 0 days, and eventually to earn a lot of money out of it. So though the path may look simple, finding a crash and reaching to the place where you have full-fledged weaponized exploit in place and earning money from bug bounty of that particular exploit is quite a longer journey and quite a tedious journey as well. So we will, as of now, focus only on finding crashes, and maybe if time permits, we will try see if we could do some basic analysis of the crash. So fuzzing process. So this is a simple diagram you can see here. Can somebody confirm if my cursor is visible?
Yes, Rushikesh, we can see it.
Awesome. Thank you. So at the mid left, you can see start program as a blob. That's where the actual fuzzing process begins. So what exactly we do with this is we trigger a particular program. This is just a very high level overview of fuzzing, maybe in form of a state diagram we can consider. So it's basically we trigger a program. The program starts, it consumes some input. When the input is consumed, we keep on monitoring the behavior of that particular program's health. When I say health, it is to convey that we are trying to understand if the program is behaving normally or if there is any anomaly present. Like, in some scenarios we give maybe a huge string of alphabets, say 1 million A as a characters, and then the program hangs for some time. So that is actually changing the health status of the program. Could be other way around, if we feed a program with 1 million A as a characters, the program may crash. Then again, that is a deviation in the health status of a program. Okay, so here we are checking the program's health. If the crash has occurred, then we will be going for triage crash option, this blob, and at triage crash we will be trying to see if the crash that's been produced has already been produced by our fuzzer. If not, then save the test. If the crash is already known, then go and start the program again. Now here, many a times the invalid input may cause program to stay in a limbo or maybe in a hanging state. In that scenario, we are supposed to wait for some time, maybe 20 milliseconds or 60 milliseconds or something, and then purposely kill the program and then again restart the program. So this is basic, we can say, process of fuzzing. Okay, so now let's go to next slide. Yes, one of very important step in fuzzing is test case generation, because it is the test case which is causing that particular behavior. So the more interesting behavior we want, the more meticulous we should be about picking up test cases. So either we can generate them or we can copy them from some source or something. So here, as we can see, understand the first target. Most of the bugs we see being reported are onto file parsers. Reason being, it is very simple to kind of create and mutate a file and feed it to a particular program. Less number of bugs are found on protocol parser. Reason being, protocol parsers are majority of the time very custom and very specifically designed and developed programs, and many a times the even valid set of inputs files which are, or other inputs which are required to be consumed by protocol parsers are not openly available. So there is a bit of we can say challenge there, but that's not impossible. Okay, methods to provide inputs. In majority of cases, it is some input function which consumes the input. In case of our target, it's going to be a simple file consumption. So here, as mentioned, there are like servers and browsers usually been considered. Apart from that, there are standalone programs as well. So we would be actually looking into standalone program to fuzz. So servers, they consume inputs through either protocols, HTTP, FTP requests. Other protocols also bring in requests like rsync and whatnot, headers within requests. So that is one way. Other ways for browsers like HTML files, PDF files, images, fonts. For browser in itself is more like an operating system nowadays. It has grown up to that level. So there could be an equal amount of possibility that there is a very specific library used in a browser which is vulnerable to a very specific memory corruption. And if we feed that interesting input which is causing that library to fail on memory, then probably we can trigger the same memory corruption in whole. We can trigger the memory corruption to compromise whole browser as well. Apart from that, technology used within the target. So this is mostly for browser. That's maybe JavaScript, SVG, DOM, WebRTC, WebAssembly, and whatnot. There are a number of other technologies as well nowadays. That is not focus of our session for today. So test case generation, another part, fuzzer logic, modifying valid input and generating inputs. We have already discussed on this, yet I'll try throw some more light on this. Fuzzer logic is something where, okay, before going further, let me give you very simple definition of, one more definition of fuzzer in very simple words. Fuzzer is nothing but some set of instructions being executed in infinite loop. Simple as that. So basically, if we do not purposely stop the fuzzer should not stop at all. If the fuzzer has been written in a proper way, it should never stop at all unless we manually stop it. Okay, so fuzzer logic, now it depends on like how you basically want to navigate through your target program. Now here comes something called as instrumentation. Probably we will be having slide on that, but that's actually a separate topic of discussion, maybe worth 4 or 5 hours of discussion is required to gain basic understanding on instrumentation. For those who had done a bit of programming, like hello world in C programming or something like that, whenever we insert a printf statement and whatever we try to print there, that is nothing but a basic level of instrumentation. Now, in case of fuzzer, what instrumentation is, we try to kind of add a lot of code, or we can say health status monitoring statements in the target program, and then we run our fuzzer with those particular inputs from the status monitors. So that is, we can say, is one of important aspect of fuzzer logic. Then modifying valid input. So in case of fuzzers that we would be seeing today, that is AFL and Honggfuzz, there we can say mutation engine has been provided by fuzzer itself. And the last point says like generating inputs, which is more relevant to browser, or where we can say grammar based inputs are required. So there people usually write scripts with grammar, like Domato have it. There's one more, Dharma also have a similar type of grammar relevant fuzzer in place. So that is mostly onto test case generation. So another aspect is crash detection. This is very important part of kind of health status monitoring of a program. In simple word, if we don't want to write a very sophisticated fuzzer or something, and if we don't want to use AFL or Honggfuzz or any other openly available fuzzers, then all we can do is like we can write some logic which will be generating interesting inputs, and then we can link our program to a postmortem debugger. I mean, we can link our program to a debugger in a postmortem mode. So every time the program is crashing, our debugger will pop up. Okay, so that could be a simple way of detecting crash and doing further analysis, where in our case we would be using AFL and Honggfuzz. They have their own crash detection engines in place, so we need not worry about that. So some of the debuggers you can see here are like WinDBG. This in white is WinDBG. The one on left side black is GDB, and the one on right side black is LLDB. LLDB is a debugger usually shipped with Mac and mostly available with Mac only. Crash detection. So as I have already told you about instrumentation, one of the instrumentation approach apart from AFL and Honggfuzz's instrumentation, we will be using address sanitizer. So what is exactly address sanitizer? By the time we will be looking into demo, we will get more clear idea about address sanitizer helpfulness. But here I'll tell you in maybe a couple of lines. So if a program crashes with a memory corruption as a reason, and if that program has been built with address sanitizer as an instrumentation tool, then we get to see some pretty outcome. Like you can see here, 1786 error address sanitizer seg-v, that stands for like, seg fault on unknown address something something. So they have given actually address like, then program counter, that is PC, then base pointer BP, then stack pointer SP, and then they have again gave some understanding of why this corruption would have happened. So there are like these two lines just below the red line which says the signal is caused by a write memory access. So there was actually a memory violation when the write operation was in progress. So this behavior is more dangerous compared to read memory access. And now the second line will probably give some more information as well. It says like, address points to the 0 page. So this outcome we see here is probably a null pointer bug, which is not really much valuable, but yes, it does carry its own weightage. But that's not part of our, scope of our session, but I just am trying to explain you some of the usefulnesses of address sanitizer. Had the same target not been built with address sanitizer, all you would have seen there is like, core dumped, segmentation fault. That's it, only 2 line. No stack trace, no these details, nothing about registers, no, we can say basic analysis of the crash, nothing. And in that scenario, if you do not have any such basic analysis in place, then it usually takes at least few hours, from few hours to a few days for a researcher to do the root cause analysis and then further do the actual patching and other things of the bug. So address sanitizer actually saves that all time and efforts as well. Crash file reduction. This is another aspect where now assume we have a fuzzer in place, we were able to find crashes. Now the interesting part of fuzzer is, or fuzzing is, we basically mutate the legit input file and then again we feed that file to the program. In this process, sometimes the set of characters present, inserted in the legit files grow exponentially after some time. And it happens so that a very specific set of characters are causing memory corruption. And rest all of the characters are kind of garbage. Even if they do not happen to be present there, it is just fine for us because the crash still can be triggered. So in such scenarios, crash file reduction comes handy. In case of browsers or where grammar-based inputs are consumed by a fuzzable target, crash file reduction has to be done manually. But in our case, thanks to AFL actually comes up with a utility which does the crash file reduction to only interesting bits or bytes automatically. We will look into that tool as well. We will be seeing demo of that tool as well. Crash analysis, that is as of now out of scope. As I have already told you, that takes quite an amount of time. We will try discussing if we get to find some crashes in our program, in our fuzzing target. We will discuss about address sanitizer onto those findings. So types of fuzzing. We would be trying to understand more about mutation-based fuzzing. So what is mutation-based fuzzing? It basically is a method to, we can say, introducing small changes to a valid input which is being consumed by the program or the target program. Here we would be looking into American fuzzy law. Don't go for this GitHub URL. We will be using different version of AFL. AFL is better because it gives us compile time instrumentation. What does exactly compile time instrumentation means? It is as good as inserting a printf before building the executable. So this printf is our, we can say, program input to the target program. Simple as that. AFL is better because we can insert such inputs. Rather, AFL has its own set of compilers in place, which kind of inserts these instrumentations to the target program source code by the time we are building that particular target program's executable itself. So the effort of finding interesting places to insert instrumentation has already been taken care of by AFL here. This instrumentation does not only check the health of the program, but it also checks the we can say execution paths being triggered by our inputs into the target fuzzing program, and that is nothing but beta coverage. Okay, seems there are questions. Give me a moment. Okay, it's been answered. About slides. Slides are really not important. If you want, I'll share them. Harshit, do you recommend me sharing here? Is it possible to share?
You can share it as an attachment in the chat box. Or
Okay.
you can share it later to me and I'll share it in document.
Okay. Okay, to all attendees, the present state of slides is a bit in development, but that will definitely help you. So I'm sharing the slides with you right away. Maybe a refined version we can share later. This is okay. Meanwhile, this upload goes on. We can discuss. Okay, intelligent test case streaming. So yes, many a times it happens that, as we have already discussed in case of test crash test reduction approach, like what we do, we remove the unnecessary bits and bytes from the program, and we only keep the interesting bits and bytes which are actually triggering new paths or new execution paths into particular target for fuzzing. Okay. Yes, and the last point is really very important. When AFL has been written, it was written with very sound thought of all activities a researcher has to do in vulnerability analysis. So utilities which comes handy during fuzzing and after fuzzing as well have been very well made available in AFL. like as I have already told you about test case reduction program, then corpus minimization program, then coverage mapping program, then then again setting up AFL or rather fuzzing target for a better speed as well. So like there are many we can say interesting utilities been provided by AFL. So is the reason AFL is considered beta. Okay, I think it's demo time. We should wait for a couple of minutes for this PDF to get uploaded. My bandwidth is honestly depleted because of the video being shared and the upload being done. So let's wait for a couple of minutes for that. Meanwhile, we can discuss the setup. We would be our target program for this session is going to be tcpdump. So what tcpdump is? tcpdump is we can say a network packet monitoring utility, and this utility can read packets from a network interface, or can read a packets from a saved file as well. For this particular target or this particular program to be installed properly, libpcap is an important dependency. We would be using version 4.8 of tcpdump. This is kind of a dated version. Reason being, there are some bugs which are, there are some security vulnerabilities which are available in tcpdump's version 4.8. And in our session to show like how we can fuzz and how we can find a vulnerability for demo purpose, I have purposely considered this particular deprecated version of tcpdump. So yes, meanwhile, okay, the file has been shared with everybody present in chat, so you guys can download and we can begin with the hands-on. Okay, so those who have already in place Ubuntu 20.04 LTS box, open their terminal and punch in this particular command: sudo apt install space gcc space make space git space wget. You want me to write this command in here chat, or are you guys good? Install gcc make git. For those who are running on low bandwidth like me, I'm typing in commands here as well in chat box. Okay, so this should run. Okay, so these are some dependencies we need to get in place. So these dependencies has already been emailed to you. Is there anybody who is not having that email where these dependencies are not shared? There could be a possibility, like somebody might have registered after organizers triggering the requirement email. If so, please leave a message here so that I'll paste this whole thing again here. Okay, seems everybody have. What's the matter? Seems pasting is disabled. Can organizers help, please?
Hi, Rushikesh, what is the issue?
I'm unable to paste anything in the chat box.
Just let me check.
Awesome, Ravi. Thank you for acknowledging. Organizer seems paste is disabled, maybe by accident or
I'm just
something.
checking it.
Okay. Yes, you need to enable sources. For those who are facing the problem regarding sources, let me show you some simple tweak. All you need to do is, press Control F1 so that this particular type of window would be shown. Just type software and click on the first icon here. Okay, something messed up. Let's go settings and go to Ubuntu software here. You can see the source code enabled. And all you need to say close, it will ask for reloading. I do not have internet connection on this box, so eventually the reload will fail. Yeah, now it is asking for download. No point downloading that amount of data as of now. So yes, I have already selected everyone in meeting to send or paste the thing. It is not
Can you try
working.
to type it something in the chat box?
I
Say
can.
hi or something.
Okay, so I can type in, but I cannot paste, it seems.
Must be issue with copy paste restriction or something like that.
Yes, could be. No problem. But okay, then probably attendees, my humble request, you have the PDF with you. Those are the slides in there. These all commands are also present. If you can navigate to the relevant page, it would help. Okay, I assume most of you have this particular command up and running. So let's go to next slide. Setting up AFL. So this is also, I mean, the previous slide was actually, we can say, a prerequisite to have AFL++ installed properly on our box. We will be using make source only option, as that is less time consuming and requires less amount of resources. So let's go to the folder AFL++. Okay, seems everything here is already been built. So I'll new AFL. Yes, I have shared a PDF. It's there in the chat. If you go back to 1631 hours, you could see the PDF shared there. And that's been shared with everybody. So you should be able to access that. Okay, so now I am navigating to new AFL, you guys should be navigating to AFL++. And then let's see what the command is. Okay, simple. Say make source only. So say make source only and press enter. So this is building whole AFL++. As of now, it will be building some set of tools, not all set of tools which are being shipped with AFL++. But those set of tools are really more than required for our today's session. I think build process is complete. Yes. Now let's just do a quick check to see what all has been built. Here we can see these set of things. Okay. So this thing, AFL Clang, AFL Clang++, AFL Clang Fast. So these are nothing but the compilers. We would be using them while instrumenting our target source code. Another interesting tool here is aflcmin, which will be actually helping us reducing the set of input files to the interesting ones. aflfuzz is the core program we would be using to fuzz our target program. AFL show map we won't be using. If we are able to find crashes, then we will use AFL tmin, which I believe we will. And apart from that, what is the interesting thing? Okay, yes, this is another interesting utility. AFL got CPU. So by design, AFL actually can spin the number of instances which are equal to the number of processors or number of processor cores available into the system. Okay, so let's quickly run AFL got CPU to learn how many cores we have. Awesome. Here we can see pass. You can run more processes on 4 cores. So technically we can run 4 fuzzer instances on this particular machine. Okay, so far everybody is with me. Anybody needs help, assistance, please feel free to put in a chat. This is hands-on session, so I want to have most of us, running this whole exercise together. Anybody facing any problem? Okay, shall I assume so far everybody is with me? Please post some message saying you are all good or something. Am I audible? Okay. Awesome. Perfect. So we just learned about this present box, like it can have 4 fuzzing instances in place at a time with the help of this particular command, AFL got CPU. Okay, let me quickly check if I'm missing on something in this. Okay. Yeah, so we have set up AFL. Now let's build tcpdump with GCC. Now, what this GCC is? GCC is nothing but one of a compiler, usually a default compiler shipped with most of Unix and Linux flavors. This is the command to see the normal GCC compilers version. Now, let's see what aflgcc is. You can see the difference. Okay, let me type in another command. You can see this is the basic compiler, and this is engineered compiler, we can say, which again is using GCC as a base compiler, but you're using more advanced instrumentation, which has been written by author here. The one which has been developed here is by Mikhail Zalewski. He used to be part of Google security team. Now he heads some other organization. He had written this wonderful tool. So yeah, so this is a difference we can see as of now. Now let's go to that particular folder where tcpdump is. So I am into the folder of tcpdump source code. If I just run ls, I could see a lot of C files and .h files here. Okay, so now let me reset everything which was done in past. So I'm typing in make clean. Make clean basically removes all of the compile time things, and kind of resets our state of source code back to what it was earlier. I mean, when it was just downloaded. Okay, so all build files, all build time compilation inputs or generated files have been removed now. Now, let's build tcpdump with aflgcc. How to do that? So for any C or C++ based software to produce an executable, there are some basic ways of making it happen. So the basic commands are .configure and make. These are the commands which are mostly used. Okay, so now let's do .configure. But here we need to actually define the compiler we would be using. How to do that? AFL++, then AFL GCC. So now we are telling the configure script that don't use default GCC, but use the GCC I'm telling you to use, asking you to use. So here we are using AFL GCC. One more request I have to all the attendees. Now, as we are dealing with a lot of command line events here, I would recommend you to closely observe your screen, like whatever has been printed onto the screen, whatever is being shown onto the screen. Just pay more attention to that, because sometimes what happens, like there are certain errors triggered, like this is simple target, but there could be more complicated target where, like, suppose 3 different external libraries needed be used, and those libraries has to be properly set a path with and whatnot. And in such scenarios, we eventually face some kind of errors while building that particular executable from source. That time, having this habit of reading the screen always and every time helps a lot, because we can do at least a basic troubleshooting then and there itself. So is my request to attendees. Keep monitoring the screen, whatever is being printed onto the screen, more closely. That will help you in longer run. Okay, so now let's press enter with this command. So now it will be configuring tcpdump with aflgcc. If we scroll up here and if we check, while configure script was running, this message was displayed: checking for GCC, So here we got first confirmation that AFL GCC was picked instead of normal GCC. Another confirmation we got is here, checking whether AFL GCC accepts something. Yes. So every time there is a mention of AFL GCC in place, we come to know, okay, yes, our compiler, the custom compiler is being used to run that configure script. And now that's been done, all we need to say make. Now you can see this some pretty outcome with some different colored font saying AFL-CC something. So this is telling us that, okay, we are using AFL GCC and not normal GCC. Okay, let me check if, okay, build process is still in progress. Okay. So we got AFL GCC to build a particular program. We've done make, right? Yeah, we did. Now let's see the fuzzing target has been built properly or not. And how to do that? We need to see if we have an executable available. Fortunately, it seems we have. This is an executable built from these two instructions, that is like .front/configure and then make. So this particular tcpdump is our executable program here. Just before going ahead, let me show you what if we have built this particular program with a normal GCC. So I'll run make clean. This is really very important command. For every C and C++ program or project you're trying build, before starting, run this command. Irrespective of you're running that program first time, no problem, run this command. This basically cleans most of the leftovers from previously done build operations. So this is really helpful in longer run. Okay, so I'm running make clean, and now for just demo purpose, I'll run only configure. Okay, now I'll run make. Now could you see the difference here? Earlier, when we ran it with AFL GCC, there was some colored, we can say, font shown here saying AFLCC something version number was used. But here you can see no such thing has been displayed. This says, okay, we are using the plain uninstrumented form of GCC. This still will build your tcpdump, as you can see here, but this is not an instrumented target. So let's go back to basics. Okay, make clean. I would recommend you practicing these steps again and again with me. It might seem repetitive, but that will help you in longer run, because when, as I have already told, like when you will try to build some more complicated projects, these steps would become more handy for you because you have been practiced more number of times. Okay. So far, everybody is with me, or am I going too fast, too slow? Leave a message in case you have any advice. Okay, awesome. So now that we have tcpdump built, let's see what tcpdump has to offer us. Okay. In most of the command line programs available in Linux or Unix, this thing works. Say this ./ name of executable and then --help. This will give you basic help at least. So here I have seen, okay, I'm able to see something. Just a second. Like this. Now I need to find a way to locally feed tcpdump my input file. Now how this file could be fed, I need to check. File size, secret, not interested. Okay, -r seems to be a read option. So this way, locally, tcpdump can read a file. Again, beauty of most of Unix or Linux-based C and C++ programs, that they have some test directory present in most of their source directory. So let's see if we have test directory. Fortunately, yes, we have tests as a directory. And let's see if there are any sample files present. Okay, there are many. So let's pick up 08 -sunrise 08 sunrise yes. So what does that pcap mean? Pcap is nothing but a file extension used to save network traffic files. Okay, so as we are testing a program which actually monitors network traffic, eventually the program should be able to even read the saved network traffic as well. And the network traffic is saved in a file which has got an extension of .pcap. Extension name doesn't actually matter in Unix or Linux, but when you go to Windows, the extension is mandatorily required. So let's see what does it show, this command. Okay, it probably was onto the lower part of UI, so may not be visible now. It should be visible to everybody. So the command I ran was like ./tcpdump space -r space and the path to the pcap file. Okay, now this shows us some IP address, maybe some source IP, destination IP, something ESP. I don't know what that is. SPI, I don't know what that is, because that is like, that could be the custom protocol level keywords. So we need not really worry about that, but all in all, we can actually make tcpdump to read a file locally and not onto the network interface. Okay. Now there would be a question like, why are we not trying to fuzz something on network interface? So the answer is multifold. First answer to that is, to have something received on network interface, we need to run tcpdump in privileged mode. So if you are already running tcpdump in a privileged mode, and if there is a memory corruption bug that we find, then out of two categories of basic exploitabilities, one is local privilege escalation and another is remote code execution. We are missing on to local privilege escalation bugs. We would only be able to target remote code execution bugs. They are equally important, but then we are missing on LPE, that is local privilege escalation bug. Another thing, AFL by design is meant to run on local systems. I mean, AFL by design consumes input as std in, and to make AFL consume an input over network, there is a utility, again available into AFL++ directory, but is not we can say really helpful for all targets which are consuming inputs over network. And as this is more of a beginner and intermediate friendly session, I just wanted to keep things simple and understandable to everybody, so that once you get the basic understanding of the tools, then you can use all your imagination to build on top of these tools or write your own tools and explore fuzzing in all possible potential you have. Okay, so we found out that tcpdump -r actually allows us reading file locally. Now let's see what can be done further. And again, another interesting thing is this particular file is a legit file, is actually triggering the basic behavior of tcpdump as required. Okay, that said, we got like two confirmations. First thing, tcpdump now can read file locally. We need not listen on to network to have a particular network traffic in place. Another thing, we got one legitimate file in place. Next thing would be minimizing the test input corpus. Why that is important? There could be like, the usual way of finding input files is, resorting us to the best virtual friend we have, Google. Like just type in Google saying, okay, Google, say, we can say test files pcap, and it will keep on, showing us a lot of pcap files, most of them maybe from, Wireshark's pcap repository or somewhere. It could be from anywhere, right? And then we would be, downloading those files and, feeding to the fuzzer. There lies a possibility like file A and file B probably are having unique way, or rather, having similar way of triggering the same path into tcpdump. In such scenarios, there lies no point putting in these two separate files in our input test corpus. Okay, then how to basically, bin through these all input test files is, there comes the utility called aflcmin handy. Okay, so actually tcpdump has test folders, which is huge. If we see the size, 470 files are there. It will take quite an amount of time to sim in them all. So why not we do another trick? I'll explain you another approach, or rather, mix of approach here to shortlist files. Here we are. Let me go to tcpdump and then tests. Basic thumb rule of selecting input for tcpdump in majority of cases for Honggfuzz as well is keep the file size as low as possible. So here I'll simply sort the files with we can say low number of bytes, and I'll pick up something interesting here. Okay, so I have picked up some set of files, and the maximum size we can see here is 114 bytes. I'll go here. I see demo input. Copied those files into demo input folder. Now back to terminal. I'm creating corpus minimization directory here. Today the date is what, 28th of August, and I will call it cmin. So this is the name of my directory, 20th of August cmin. And now let's run the tool aflcmin. -I stands for provide the input directory from which you want to pick up the interesting files. For that I have said demo input, because that is where I have kind of kept some of the files. -O is where you want to save the shortlisted files. That would be 20th August cmin. Then say space --, and then write tcpdump -r. Okay. For those who need help, I type in here as well. aflcmin -I demo input -O -r. Okay. Now I'm running this command and let's see. Okay. So there are a couple of alarming things we can see here. First thing is we need to use another AFLC mean tool because this is something from older version. So let me go back to, okay, I'll tell you about that for sure. So usually zero sized inputs are discarded, so that would be removed. And this warning is equally important. It says all test cases has the same traces, check syntax. So now we need to go and check what exactly is missing in our command line. So I'll just recreate this whole command line, and at the end I'll add at. Yes, to answer microsec, yes, by doing this we are filtering out, we can say, redundant files. They may not be useless, they may be useful, but the redundant files, like, you know, if both, if, as I have already explained, if file A and file B, if they produce same behavior using same execution path being traversed, then there is no point including both of the files into our input test cases. Either of the file will do, but then we cannot do that manually because I mean, yes, we can do that manually, but that does take time. And AFLC min is already there, so yeah, repetition is avoided. So yes, so that is how it is. Okay, so coming back to the terminal, it is again the same old command line I'm using, but I have appended after -r space @@. And now let's see what it does. If, yeah. So what it was doing, it was, okay, file exists. Okay, yeah. Microsec, does that answer your question? Okay, awesome. Okay, so here now we have like 8 files and they are saved in 20 August CMIN folder. Now comes the next part. Okay, I forgot to reference slides. Something is missing. I think we are good. Okay, AFL analyze is missing. Okay, before going further, if you guys remember at the beginning of the session, I have mentioned, like, you know, there could be a possibility that if you are, like, you know, running a fuzzer onto maybe a protocol parser or something, custom files or rather, you know, custom fields are present into that particular parser which are not publicly available. In such scenario, how to learn the file we are feeding to our fuzzing target is actually relevant to the fuzzing target. For that, they have, I mean, AFL provided a fantastic utility called AFL Analyze. Okay, before going further, I probably need to tell you to do one more thing. Let's go to AFL++ and then run sudo make install. This will install your AFL's instances into a user bin directory, so that every time you're trying to use a particular executable from AFL++ folder, you need not give the absolute path of AFL++. All you can do is like just type in AFL and whatever command, like say AFL cmin, or here as we're using AFL analyze. Okay. So tcpdump. Okay. So in afl++ folder, run this command sudo make install, sudo space make space install. That is not purposely told to you previously because I wanted you to get habituated to absolute paths mentioned into the process. But yeah, computer world is mostly run by we can say lazy people, so it's better to have those things in user bin. Okay, so back here, AFL analyze. AFL analyze -I. I'll go to same file, tests 08 sunrise ASPCAP, and then tcpdump -R. And now let's see what it does. So there are, if you see on the screen presently, there are many interesting, we can say, inputs shared. I'm not going to delve deeper into any of those fields or the keywords because the discussion will take us far deeper into other part of systems than fuzzing. Yeah, I'm going to tell you how to infer if the file is interesting. And if you see the white line I have just highlighted below the red text, it says analysis is complete, interesting bits 100% of the input file. That says whole file is a legit file for our fuzzing target program. Okay, so now again, let me reference back to slides if something important is missing. Okay. Yeah, manually check the time the target binary is taking to execute the test file. Oh, sorry. Excuse me. Why this is important? Because if it takes more time to kind of execute the target binary with the given legit text file, that is going to impact the fuzzing speed as well. And remember, one of the important aspect of fuzzing is more executions per second. So time taken by every input to execute is important as well. Yes, and the number of files does not always matter. Yes, fortunately, AFL has been designed with such an interesting approach that even if there are 5 files you give them, you give to the fuzzing program and fuzz with AFL, it probably will try to produce all possible variations and combinations which are pretty much compliant with the instrumentation that we have inserted at the compile time. So only the volume of files is not required, and that again answers the microsecs question. It's not the volume that is important, it's the quality that is important. It's the quality of file, if it is actually tracing some new path, that is more important. Okay, now let's run AFL. So running AFL has got a simple syntax: AFL -fuzz -I input directory -o output directory. If the target is really heavy, we need to edit -m option. -m stands for how much memory is required for this particular program to execute successfully. Okay, but in our case, we will not use -m. We will let AFL decide whatever the -m value should be. Okay, and then say -- space dot /tcpdump -r, and then @ Okay, just a second. I'll type in command here as well. This -I input folder path -o output tcpdump -r etherpad. I have typed in the command in chat box as well. Okay. So now here our input directory is that cmin directory, right? So let's say demos input. No, it should be 20 August cmin. Output directory we have not created, so we need to create an output directory. So let's create output directory mkdir 20 August output. Okay. So let me edit this output directory path to 20 August output. And now let's see if this command triggers everything required. Bingo, it didn't. If we see everything that's been highlighted with red, that says there is some problem, which is preventing AFL from executing in a full-fledged way. Now there are multiple ways basically to address this thing. Either you can type in this thing with full privileges, so you need to say sudo -s and then type in this whole thing, that is echo core, and press enter. Easier way is having run AFL system config with sudo privileges. Alex, yes, we did run cmin, where if you could, let me show you. Yeah, Alex, can you see this? Yeah, narrowed down to 8 files. Okay, no problem. That's just fine. Every question is equally important. Please keep on asking. Okay, so now let me clean the screen. You would be kind of, making everything favorable from operating system point of view for AFL to run smoothly. And for that, to do multiple settings in a one go, this is a simple command, which again AFL++ comes up with. Sudo space AFL-system-config and press enter. This does all, or rather majority of we can say settings required. And now let's see if the previous command aflcc runs. Awesome. Something happened. Something started. Now, hopefully everybody should be able to see this particular screen wherein it says like, American fuzzy log ++ 3.13a default fast and whatnot. Okay. One major matter of concern, which fortunately we did not face here, is this thing, last new path. It happens in some cases, like, the program is properly instrumented, the fuzzing session started properly, but new paths are not being discovered. So the answer to this particular challenge could be multifold. First thing I would recommend in such cases, checking the @ options. In some cases, if you append @ at the end where the input has actually, where the input should actually be consumed by the target fuzzing program, that works, and that basically spins more new paths, or rather that basically finds more new path. In some cases, absence of @ in the command line helps triggering more path. There are some targets which behaves in this way. So this is more of we can say a bit of trial and error approach we need to follow here. Okay, now onto this particular screen, we can see runtime, which is like for how many minutes, hours, days this particular fuzzer is running. Last new path, when the last new path was detected or found. Again, we can see the timeline to that as well. Total paths, number of paths. Last unique crash, last unique hang. So far, no unique crash, no unique hang. Okay. Now with the AFL++, this fuzzing strategy yields has something to be modified. Okay, so let's stop our fuzzer. And what has been asked us to do here, let's insert that particular keyword. So here we are supposed to add -caps D into the command line and then rerun. So the fuzzing strategies are like, bit flips, byte flips, arithmetics, known ints, dictionary, havoc, splice, and then multiple, like, custom mutation also can be inserted here. We won't be discussing anything on that part because that again will take our discussion to some different level. As of now, my motive is to make you familiarize with like what exactly fuzzing is, how this can be done at very basic level. Okay, so now let's run this fuzzer for some time. If it finds a crash, that's awesome. Otherwise, we have a different option available. Okay, meanwhile, we can do a thing. We can run aflcmin on complete tests folder present in tcpdump. New cmin tcpdump -r. Oops, what happened? Okay, -i-o. I'm letting it run for some time. Reason being, there are 470 files in place, and it will take a good amount of time basically to minimize that whole test folder to interesting ones. Oh, fortunately it didn't. But if you see the number of files which have been narrowed down to are like 180 files. Okay, so that is huge number. All right, so let me stop the fuzzer here and let me go back to slides. So this is like, now you are able to actually instrument a particular program with AFL's default instrumentation and then build the target program and then fuzz that particular program with the command afl-fuzz. Okay, so far everybody is with me. Anybody needs any help, any inputs, anybody stuck somewhere which I can help up with? Please share in the chat box. If you're good, then also please share in the chat box. Okay, seems everybody is on same page. Thank you for your inputs, guys. Okay, so that was the way we have checked. I mean, we have built TCP with AFL's instrumentation. Now let's build AFL with ASAN. Okay, So the first command should be make clean. Now run. Let me check if AFL is in path. Yes, AFL is in path. So cc AFL-gcc and yeah, sorry. Yeah, AFL-gcc./configure. Let me clean the screen and run it again. Okay. Now, while running make here, we need to do a bit of edit. All we need to say AFL use asan equal to 1. This is kind of a we can say a custom way of telling source code to consider AFL's address sanitizer instrumentation, and then say make. Now, if you have observed something on the screen, you can see here asan mode ratio 33%. Okay, that said, asan mode is now enabled. If you go back to the previous build session, yeah, somewhere here, you can see there is no presence of asan mode, right? But here now we are building everything with address sanitizer. Okay. Yes. So now we have built the program with address sanitizer here. And now let's see if we could run the same command, that is AFL fuzz, and see the difference. Okay, I probably need to insert -d again. Okay. The basic difference you would have observed so far is speed is quite slow here. As we are having very small target fuzzing program in place, it may not be significantly visible, but otherwise the speed happen to be, you know, reduced when it comes to address sanitizers instrumentation. Reason being, whenever we do address sanitizers instrumentation, or for that matter in instrumentation, it has got its own performance overhead. What does that mean? Is like, suppose for every 1 kilobyte in the memory to be fetched, accessed, there is another 1 kilobyte has to be allocated, and again that has to be fetched and accessed. So at least the performance overhead is at very low level, it is at least 9 to 10 times of the normal execution speed of the program. Okay, so this way we have built the target with address sanitizer. Now, for the demo purpose, let me show you some crash, like how tcpdump would be finding a crash. All right, awesome. So what I did here for the demo purpose, I have downloaded another version of tcpdump, which is quite kind of updated one. So if we say if log 1, it says 9th March 2021. And if we go here and say git log 1, it says October 25, 2016. So obviously there are some more test cases into this particular folder of the latest tcpdump directory. And what I'll do, I'll just copy some interesting looking files from those from that particular test folder for our analysis. Say overflow.
I guess looks like Shikesh has some internet issue. He just dropped out. So let's wait for a couple of minutes. He might join soon.
Hello, admin, did I miss anything?
No, we miss you actually.
Oh, I'm sorry. My apologies. From where I was disconnected, I'll repeat that whole thing.
You can take back us to 5 more minutes. So we are even not sure when we lost you or because.
Okay, no problem. Okay.
ASAN, I guess.
ASAN. Okay. Oops. Why it is asking me to join the meeting again? Is my screen visible?
No, we are only seeing a black screen.
Okay. Check. Check. Is it visible now?
Yes.
Awesome. Let me check if there is anything. Okay. Okay, we were copying heap overflows test from latest version. Okay, awesome. So what we did, we basically copied some overflow causing files from latest edition of tcpdump into our we can say folder to be given as an input folder. So we created another input folder where we have saved those all overflow causing files, and then we triggered a fuzzer with that particular files as that particular folder as an input. If you see here, it's the same command, no difference. So, I think, yeah, it should be here. Okay. Everybody's with me so far? Awesome. So, and fortunately, we were able to find one crash as well. And we were about to see like what exactly is happening in that crash. So we spawned another shell here and we navigated to the output directory, which we have defined as an output folder for our fuzzer. So we are into that directory and we just try to see what all is present in that directory. So there is another directory called default. Now we are into that directory. And now I run ls-l, I could see again 3 directories and some set of files. So as I've already explained to you earlier, I would be more interested in crashes. So let's go to crashes and run ls. So this crashes folder is pretty user friendly. Okay, awesome. Everybody's with us. Let me take the chart. Okay, yeah. All right. So if we say cat readme, it will tell us what exactly was the command line option we have used, which triggered this crash. So it says afl-fuzz space -i space the input directory space -o, the output directory space -d space the executable and whatever the arguments required for the executable. Okay. So now let's run this particular input file with our target. How to do that is simple. tcpdump -r. Let me go to the file which is actually causing the crash. Oops. Wow, now there are 2. Awesome. 0 0 and then press enter. Wow, something's happened. You see, address sanitizer actually told us that it is a heap overflow of read of size 1. Where it happened is happening onto this particular line. So it is actually giving us a stack trace as well. It is showing us the details about the buggy address as well. And that's it. Now, let me take you to another thing. Okay, let's go to, okay, let's create another folder. Here we would be copying all files from tcpdump to gcc tcpdump. Okay, non-ascent tcpdump. Okay, let me go to non-ascent tcpdump. Here, I'd be running my clean and then running configure. Okay, let's run it with configure. This is just to show you the significant difference when we have some finding in place and then we have to analyze that finding. Wow, there are more crashes coming in. Oh, meanwhile, if there are any questions, please feel free to ask in the chat box. I actually want to share something about this time which this make command is taking to, complete or rather build the executable. You would have observed, like, it is taking quite a significant amount of time to, run this whole make command. Is there any other way out to expedite this particular we can say make commands execution time? Okay, so there is okay, how AFL is different from AFL++ in terms of performance. AFL is actually we can say predecessor of AFL++. So in case of performance, so now there are certain very interesting cases which have been missed by AFL, the older AFL version, which the new AFL++ can actually cover. So it could be a scenario where AFL++ AFL has been run for like say 10 days and there are no bugs found. Wherein on same target, if we run AFL++, AFL++ would actually find some interesting bug within like a couple of minutes. And that happened with many of the targets. So that is something I believe is really interesting in case of AFL++. What exactly those technical details are, I honestly feel this is not a stage to discuss, reason being those who are just beginning with no programming knowledge into fuzzing, they will get discouraged. So we can take this offline if that works for you, Ravi. Or if this answer serves your purpose, that's also fine. Okay, is it used for what purpose? Well, sorry, so Tar, we are using AFL to find bugs, mostly memory corruption relevant bugs into the programs which have been written in C and C++. Does that answer your question, Sudha? Okay, awesome. So yes, how to expedite this make, or rather, how to reduce the make commands time, or whatever happens after make command. So let me make clean. Okay, let me stop the fuzzer as well so that we will be able to use whole computational power here. Make -J $and proc. This will tell make command to use all processor cores available in the system to build our product or to build our target program. This -J $and proc can be replaced by 1. So in this scenario, only 1 core would be used. If we replace it by 2, only 2 cores would be used. 3 cores would be used. 4 cores would be used. Now, if we are not much aware like how many cores or rather how many usable cores we have, best approach is -J $and proc and let it run. Usually it takes lesser amount of time compared to normal make command, because in normal, see how quick it was to build the tcpdump. In normal make command, it only consumes 1 core out of our all cores available in the processor. Here, now we are using all 4 cores. That's the reason it was built quickly. Okay, so far everybody is with me. I wanted to show you something. Yes. So now let me run tcpdump -r, and now let me go to the folder where the crash causing file is there. Where the crash causing file is saved, -o output, and then default crashes id and say 0. Okay. Can you see the difference? This is an outcome of same TCP dump when it was not instrumented with address sanitizer. All it says, like, invalid address and something. No root cause, nothing like why this bug was triggered and what exactly is the silly problem. Now, if I go to TCP dump and I run TCP dump -r 28th August output default crashes ID. Now you see this. Now imagine you are a vulnerability researcher and you need to expedite the analysis. Which one would you prefer? Obviously, address sanitizer one. Okay, so far everybody is with me. If any questions, if anybody is stuck up, yes, ASAN is beautifying it, or rather, I would say it is doing basic analysis required, which actually takes a lot of time for a researcher to do otherwise, because manual efforts take more time. Okay, so far everybody is with me. Are we good to go ahead? Yes, Ravi. Okay, so Ravi has a question. He asked, like, can we find crashes using non-ASAN binary and then run that crash on ASAN version? Yes, that is possible. But then there is one advantage and one disadvantage. Advantage is you will get better speed because you will have less instrumentation passes in your binary. Disadvantage would be there are certain crashes which are only triggered when address sanitizer instrumentation passes are inserted. So you would be missing on those crashes, which are only triggerable when address sanitizer instrumentation passes are inserted in your source code. So does that answer your question? Awesome. Okay, Radenza. Considering the time we have in hand, I think we should skip Radenza. As such, this thing is included into the slides that I have shared. And Radenza is basically a test case generator where we can provide a legit test case, and whatever the mutation that we have seen in the AFL's user interface here, like, something here. Part of that mutation is done by Radenza to generate more files. Okay, so those files, again, it would be better to run those files through aflcmin to get interesting files only for our purpose, and that is most of it. So in the PDF that I have shared, these all commands are present. You can try. I think we have Honggfuzz to cover, so I'll expedite a bit. Okay. Trimming down test cases. CMIN we have already seen. Parallel fuzzing. Yeah, this is something we should try. Okay. So now we have something called as. Okay, let me first remove 28th. Okay, sorry. RM-RF 20th of August output. 20th of August output. I have recreated the directory so that whatever the previous traces were into the directory have been now removed, and now directory is clean. This particular directory, 20th August output. Now let's run our same command, aflfuzz1, but append certain things. After -d, say -M space master, or any string you like here. Okay. Check. I think the chat box is messing into my. Yeah. Master. You can put in any string there, not a problem. Okay. After -n. And then rest of the command should be same, and then press enter. So now this has spun one instance of AFL. Now what I'm gonna do, AFL-fuzz -i. Okay, crash and was back there. -o, 20th August, same syntax, no difference. There's only one difference. Okay, that says outcome -d. Now here -S and say slave 1, and then say -tcpdump -r @. Now for saving time, I just am copying this command line thing and pressing enter. Now if you see, there is one American fuzzy loop running in the back, one running in the front. This says master, this says slave. I'll run another one because I have 4 cores, so I can run 4 instances. Now here all I need to do is change the slave's name, -S space slave, say 2, and let's begin. If you see here, slave 2 has spun up, right? Now I have like 3 instances of AFL running on the TCP dump onto the same target. Now the file has been, the input files have been shared. Whatever the inferences have been generated, those also have been shared. And now everybody is in the process of finding bugs. All these 3 targets have been trying to find the bug. No, this is fine. We have like only 4 cores, so we can manually go and see the thing. As well as we are onto a proper desktop version of Ubuntu or Unix operating system flavor, we are good to see this. But what if we are running it on headless? Is there any way we still could check the status of multiple instances of same fuzzer running on same target? Answer is yes. Again, thanks to Michael Zalewski. The command is afl-whatsapp, afl-whatsapp -s, and then path of the output directory. That is it. Here it gives us a summary of the status of all the bugs or the behavior of all the fuzzers being run in the background. Now here, if we see 3 fuzzers are alive, 4 minutes have been done. Excuse me. Number of executions 24,000. Forget everything. The most important part is crashes found, 1 locally unique. Now all we need to do is like go back to the fuzzer and check which fuzzer actually triggered the crash. So it says slave 1. So now all we need to go is like, go to slave 1, say 20 August output slave 1 crashes, and you would find the interesting file there. Okay, so far everybody is with me. Please type in a comment. Awesome. I'll just reduce number of shells kept open, and I'll close down all the fuzzers as well. Okay. Let me check if I have any shell available. Awesome. Exit. Okay. All right. So far, what we have learned is like, we tried speeding up fuzzer using multiple instances. We tried build AFL with we tried build TCP dump with AFL. We tried build AFL with we tried build TCP dump with AFL and address sanitizer. Now one more thing. This thing I want you to observe on your own machine afterwards, because we have some less time and Organizers, can I request for like 15 more minutes if that works for you? Because
Yes.
one whole fuzzer is.
Sure, Rushikesh, we can extend that.
Thank you for your generous help. Thank you. Okay, without losing any time, I just want to cover as much as possible. So I will skip this portion as of now because these things you can monitor later as well. Why this slide was included, I'll tell you. Because the next way of building TCP dump we are going to learn is dependent upon this slide. What it says, did you observe something like stage execs, total execs, execution speed, messages during execution? Reason being, in my normal 4 or 5 hour long fuzzing workshop, I usually make people observe every of this field in different instance and then check the these values in incoming slides behavior as well. But as of now, you can check this afterwards as well. All you need to do is check these values on your AFLGCC with ASAN or AFLGCC without ASAN build of TCP dump. Just note them down and then let's proceed further. You can do that afterwards as well. Slides are with you, so not a problem. Building TCP dump with CLAN. Now, if you see a couple of slides back, it was saying speeding up the fuzzing. Here, the general observation, not always, but the general observation is if we build a particular or rather majority of programs with CLang as a compiler, then the executions per seconds have been observed to be more compared to the targets which have been built with GCC as a compiler. Thankfully, AFL again comes up with its own CLang or rather engineered CLang compiler. So let's quickly go back to our shell and start building AFL with CLang. So first step would be make clean, and let's see if AFL CLang is in path. Yes. So now here, as we have small amount of time in hand, here again we have 2 versions of CLang in place. In older AFL, the CLang fast used to fail in certain cases, but in AFL++, CLang fast doesn't fail in almost all cases. It works properly. So here we would be just assigning AFL CLang fast. If somebody is curious, let's go back to AFL++, and if we say grep CLang, we could see all CLang entries. So we are interested in either CLang or CLang fast. Just to save on time, I'll directly go to CLang fast. Okay, and I'll say configure. In earlier version, that is like AFLGCC, we have observed the executions per second were like around 100 to 150 executions per second. Let's see what we got here. Usually we have a better number in case of build which have been built using AFL CLang fast. Okay, I am gonna run same command here. Oh, sorry. Probably I need to type in here command. Same command, no difference. -I crash in -o. Okay. Okay. Let's remove that file. 20. Folder output. mkdir 20th August. Sorry. Output. Okay. -d -tcp dump. Sorry, I'm missing on something. Okay. -r @rate. Now let's see what's the execution speed. Did you observe the difference? We were like hardly 100 to 150 executions per second, but now if you see the exec speed here, it is 1045 to 1054 executions per second. That's the beauty, and that's what is required. Like when we are trying for a particular target, the more executions per second, the better it is. But that's not the only criteria, but it is advisable to have more executions per second. So now you imagine you're running 4 instances. So now there, what were you getting? Like, hardly 400 or 500 executions per second. I'm sorry, I have closed that shell. Otherwise, I could have shown you. No, this is not with ASAN. We can quickly try with ASAN as well. Make clean. So. Here also there's one more thing you would observe. It will be a little slow. Oh, seems ASAN was not consumed. Why is that so? Strangely, did not accept ASAN. There's other way we can use. So we can say C flags and -f sanitize equal to address. This way we are tailing. Sorry, probably need to do this. Make clean. Okay. Here we need to define C flags, and in certain places, if your source code is written in C++, then that would be C++ flags, CXX flags. -f sanitize equal to address -G. G is basically to enable debug symbols, and LD flags also. I prefer writing most of the ASAN flags as LD flags as well, because some programs, they trigger some weird error, but having written in LD flags actually help. Okay, and LD flag stands for loader flags, or maybe linker flags. Okay, so now all I need to say, make -G $ and proc, and that should pick. Oops, what happened? -G $. So yeah, for those who are curious, you could see in this UI it says -f sanitize equal to address. So here I have got a proof that okay, whatever the instrumentation passes for my address sanitizer I have actually asked in configure script to include have actually been consumed and have been inserted into the source code while building the executable. Okay, and now let's see if we could get any difference in speed. Yeah, so it has reduced to half, maybe. Like earlier it was 1000 executions per second. Now it is like between okay, it is around 300 to 200 something. So less than or rather more than 50% of decrease in execution speed, but it is still better than 150 or 100 executions per second. So that's beauty of FL client fast. Okay, I just am quickly shutting it down. We have to cover Honggfuzz. Let me check if there are anything missing in slides. Nothing. Wait for crashes. Okay, expect what? We will discuss this later if time permits or if organizers permit. Let me first run through Honggfuzz. Okay, so the command can be git clone https :// github.com/google/.git. This is a command. This will basically copy, or rather, download a copy of Honggfuzz in your box. All you need to do is, yes, all you need to do is copy tcpdump to tcpdump_hong. So now process is almost similar. All we need to do here is, use compiler which was engineered by Honggfuzz for our build process. My apologies for the noise. That was my 2-year-old who was equally keen in learning fuzzing with us. Okay, so I'll just run make clean here, and I hope you all have now Honggfuzz in your path. Let me check if I have. Yes, I have Honggfuzz in my path. So like in case of AFL, the compilers were starting something like this: AFL-GCC or AFL-clang. In case of Honggfuzz, it starts with HFuzz-GCC or HFuzz-clang. Okay, so as we already have seen GCC and clang in past, now I will just directly go to HFuzz-clang here. So here, let's have compiler as HFuzz-clang, and then say .configure. Like in AFL, we do not have a shortcut to use all address sanitizers directly. Instead, we need to use the same C flags thing. -G, same thing with LD flags. Okay, there's a typo, I need to fix it. Okay. Now the same old way of checking if Honggfuzz C-line compiler has been used. Can you see it here? It says like checking whether HFuzz-clang accepts. Yes, it does, and so on and so forth. Here also you could see same thing, HFuzz-clang, and again here also, right? So now we have used HFuzz-clang to basically get things done. So make -J $nproc will quickly build our program. Strangely, it did not consume our instrumentation for address sanitizer. That says we missed something in there, or maybe it did use and it is not showing up here. It happens sometimes. Okay, so now we have built tcpdump with Honggfuzz right? Now the only difference here is name or syntax, we can say. All you need to say Honggfuzz, like there we used to say FL-fuzz, and okay, let's make directory say crashes and say Honggfuzz-i. This is something important in case of Honggfuzz. You need to give absolute path. Relative paths doesn't work in Honggfuzz. So I'll say crash in -crashes. In Honggfuzz, we have freedom to, we can say, declare a separate crashes directory. Only crashes would be saved, where only crashes would be saved. Okay, so I have defined that. Verifier. This actually tells us whether the bug we have found is already present into the folder or not. So this is kind of a deduplication mechanism. Threads. Honggfuzz is a little more friendly as far as multiple instances of fuzzer need to be spawned. Here we can do that in the in one shell itself. Here all we need to say is like -- threads, and let's give 4, and then we can even give timeout as well, like, you know, how much time shall we wait before forcibly exiting the particular executable. By design, whatever time it takes, I'm going to leave it that number. And then the executable -- dot front slash tcpdump -r. Like in AFL, we have used @@. Here all we need to do is _ caps file ____. Now this will run 4 instances of Honggfuzz in single shell. Something missed. Okay. Yeah, the name of the name of parameter where we are supposed to save crashes is crash_dir, if I'm not wrong. Let me confirm it here. Yeah, sorry, crash dir, not _dir. Yes. And now it should run smoothly. Yeah. Now you can see here crashes have been found more quickly compared to AFL, but that is not something a comparable criteria to consider here, because Honggfuzz uses a different fuzzer logic, different mutation logic to find bugs. AFL uses different logic to find bugs and to mutate as well. So I'm shutting down Honggfuzz and checking the crashes directory. Yeah. So reading Honggfuzz's crash file is also an interesting thing, or at least crash file name. The first thing it says is like what kind of signal it generated by the time the target was crashed. So this was actually SIGABART. So that was actually an abort signal was triggered. Then it tells you, like, you know, what was the program counter value, what was the stack counter value, and whatnot, right? So there are many things. You can go through these conventions later as well. And now what we can do is tcpdump -r, and let's trigger something here. 9AA. What's that? Sorry. Let me copy the file. That's simpler. Something missed. Yeah. Fortunately, our build was appropriately consuming required address sanitizer flags. So the output we could see here is address sanitizer outcome. So here is another bug, read of size 6 at some different location, ether_NTO host, right? So that covers our Honggfuzz. Let me check if something's missing onto slides. So far, good. Okay, so organizers, if I can borrow 1 more minute.
Sure, you can go ahead.
Please, thank you. Okay, so these are some basic principles we need to follow. Just because this was a dated version of tcpdump, we were able to see the crashes within a couple of seconds, but in reality, the crashes might take some time, sometimes a week, sometimes a month, something like that. Okay, so don't lose patience as well. Yes, as has been written here, fuzzing is all about randomness. So we never know what time the interesting path would be triggered, what time the interesting input would be generated, because this is all about randomness, right? And the last thing is, build your own fuzzers. That's equally important. The reason being, everybody fuzzes on whatever is available onto I mean, whatever available fuzzer is available, everybody uses that. So eventually everybody would get similar crashes, right? And eventually the bugs would get quickly patched as well, those which have been found by publicly available fuzzers. But if you write your own fuzzer, then there would be some crash, might be some crash which is only found by your fuzzer, right? So that would actually give you more interesting bugs. Target one thing at a time. Yes, unless you have 1,000 cores at your disposal, I would recommend targeting one target at a time. And modify when crashes reduce. Yes, that's about building your own fuzzers. Like it happens, you keep on running same fuzzer for years and find interesting crashes, but suddenly you see like there are no crashes being found using your fuzzer. That doesn't mean the target is more secure. That means your fuzzer is lacking somewhere to reach the interesting paths into the executable or into the target program. That said, these are my contact details again with you in your slides, and I hopefully can say that's exit 0. If you have any questions, if organizers permit, I would be more than happy to answer.
Yeah, we can definitely take a question and answer session.
Okay, thank you, organizers. So, Microsec, what is the best target to use in earlier days of learning? Pick up tcpdump because it's simple. You can pick up any simple file parsing mechanism, maybe, like some of the bin utils, like readelf or similar things, or maybe obj dump. You can pick those. Yes. Technically, memory corruption can be found in almost all type of programming languages. Now, with intermediate level code coming in picture, those memory corruptions have already been taken care of by the virtual machines. In case of Java, it's JVM. In case of Python, they have IL code manager. I just forgot the name of that. And plus they have enhanced garbage collectors as well in place. So that prevents those memory corruption bugs from surfacing, but that doesn't mean those memory corruption bugs are not present. Okay, you just need to be more meticulous, more low level, or rather, low level in case of understanding of the programming language and platform. So that is possible, not impossible, but pretty rare. And definitely you don't have support of ASAN on non-C++ programs. So does that answer your question? Just a second. Does that answer your question, Darahas? Okay, awesome. Thank you. All right, is there any other question? Okay. Okay, any other questions?
I don't think we have other questions.
Okay. So, all right. Thank you for being an awesome audience, and thank you for being an awesome organizers. My humble apologies for taking more time than estimated for the sessions. And to all the attendees, if you have any questions, I have given my contact details. You can approach me there. I would be more than happy to help with whatever I know. If I don't know anything, either I learn and tell you, or I'll redirect you to appropriate resource or person.
Okay, thank you, Rushikesh, for this amazing informative session. I am sure our participants must have found some important knowledge inputs from it. And thank you all for your participation in today's webinar session. Hope you have enjoyed it. Also, we have our next webinar workshop session on ransomware unlocked by Ashwini Siddhi on 27th August. Hope to see you there soon. Okay, that's it from our side. Bye, everyone.
Thank you. Have a great day ahead.